The team is composed of various engineers from different fields. Jasmine Barcenas as the civil engineer, Edrie Lou Balogo as the theoretical engineer, Patricia Kyla Eunice Cagalcal as the materials engineer, Joanna Beringuel as the construction and mechanical engineer, and Joanna Genesela as the disaster and risk engineer. It is our objective to design and construct the tallest and strongest structure that is able to stand on its own using only the prescribed materials.
First, I will be sketching rolled papers with masking tape tied to the fold's end to prevent it from breaking its roll. Then, I'll draw a stand out of 3 rolled sheets which will be kept together by the masking tape. It will act as its foundation or base, allowing it to stand firm and still. I will then sketch the folded sheets with masking tape fastening each roll, and they will be stacked or layered by putting each roll into its end hole.
In order to accomplish this task, we should first understand the terms equilibrium, center of gravity, stability, and structural integrity. First is equilibrium. It is a state in which opposing forces or actions are balanced so that one is not stronger or greater than the other. To avoid the collapsing of the structure, the building's equilibrium must be maintained. Second is center of gravity. It is a point at which the weight of a body or system is regarded to occur. In order to keep the center of gravity low and at the base of the structure, we built the base broader while building it smaller towards the top. If the center of gravity is low and near the base of the building, it will have more stability and help maintain equilibrium. Which brings us to our third term, which is stability. The stability of an object is the measure of how likely it is to tip over when pushed or moved. Stable structures are exceedingly difficult to knock over, whereas unstable objects are very easy to fall over. And lastly, we have structural integrity. It is a structure's ability to sustain the desired pressure without failing due to fracture, deformation, or fatigue. It is a notion that is frequently utilized in engineering to create objects that will perform their intended purpose while remaining operational for the required duration of time.
The materials in building the strongest and tallest structure are scratch papers and masking tape that is 1 inch in width and 1 meter long. The scratch paper in this activity will serve as the structure's base that supports the tower's body and will keep the tower standing still, and the tower's body, which is the main portion of the structure. In creating the tower, the masking tape will be used to connect or bind the rolled scratch papers together to make it sturdy and prevent it from falling apart.
Hi, so I am the one in charge in constructing the building. But before anything else, let me show you first the materials that I'll be using. I'm using a scissor in cutting the tape and papers, the 1 meter measurement from this roll of tape, and numerous scratch papers as the basis of the structure. After preparing these items, it's now time for me to construct the building. To start off, I first rolled the scratch papers from a lengthwise position, and after doing so, I secured them with the pieces of the 1 meter tape that I cut. This ensures the firm and secure hold of the rolled paper as it becomes a sturdy base of the structure. For several times, I kept repeating the process until I had created more than enough of these rolled papers. After doing so, I started to assemble the building by attaching first the pillar or legs of the structure to guarantee its solidified stand. At first, I began to attach its 3 primary legs in a triangular form and secured them with the tape strips. When done, I decided to connect the other rolled papers as its body for it to become tall. In establishing its equilibrium, I separated the bigger rolled papers from those with the small holes, as this is to put the ones with the bigger holes below to make sure that the structure can stand on its own while being stable due to the support it gets from the base arrangement. After testing it if it could stand on its own, there I made some modifications in which I will be explaining in the next part. And because I am a mechanical engineer at the same time, it is part of my duty to make modifications in case it will be needed for the structure to be a successful one. And like what I have said, I created a refinement plan on its base by adding 2 more legs. One is on the side so the legs would be equally distributed, having 2 legs parallel on each other, and second is in the middle to maintain its balanced stance. I secured it with the tape also. After it, I tried letting it stand alone, and voila! It was a success because it now had a steady position in an equilibrium state. And to truly confirm the structure if it is tall and strong, I performed the given 3 testing challenges. First testing challenge, I let it stand on its own for 10 counts. This counting should be the regular 1 second interval on every count. As you can see, the structure is still standing firm and tall. Second testing challenge, I positioned an electric fan 2 meters away from the structure. Turning on the fan on its lowest setting in the switch, another 10-second count will be done to observe if the structure could survive the blow. And because it wasn't still affected by the blow, it's time to proceed on the last testing challenge. On the third testing challenge, I repeated the second testing challenge, only that I increased the setting in the switch to number 2, and another 10-second count will be given to observe if the structure could still survive the blow. It still wasn't bothered and stood securely, and because we wanted to be more sure if this is a complete success, I even increased the switch of the electric fan to the highest number, which is number 3, for another 10-second count. And amazingly, nothing has happened. And because everything is a success already, I have now measured our structure using a tape measure. It measured 76 inches or 193.04 centimeters. Therefore, we conclude that our structure is not just tall, but also strong.
The Eiffel Tower is the basis of the ideal structure. By folding the paper into sticks, a strong structure can be constructed, which is then arranged into a tripod form and elevated to create a high tower, similar to the structure of the Eiffel Tower. It is because a tripod structure distributes the load symmetrically, making it less likely to topple than a flat structure as a base. It is essential to design a structure that can withstand force or things pushing and pulling on it. Gravity, people inside, the weight of building materials, weather, and environmental impacts are all sources of force. If the design is stable, these forces will not weaken or cause the structure to collapse. As a result, the building structure must be strong enough to prevent harm or danger to people nearby or inside the building. The building should always be checked for causes that could possibly cause its collapse in order to prevent potential hazards and risk.